long division, okay? In this example, I realize it's not that bad because I chose some pretty low powers, okay? But as you increase the powers of this guy, right, this takes forever. It takes up like half a page because you're just writing so much stuff, okay? So synthetic division, I know was probably optional to you guys in year 9. Maybe you did get taught it, but you didn't learn it because people can teach things without you learning it. So I'm going to go through it now because it's so much of a time saver. You guys are year 11, you can handle it. So how does it work? Let's take the same question, okay? The first thing you do is you write a division sign and you write it upside down. There's only one reason why you write it upside down. It's so you don't confuse it with this one, okay? That's all, seriously, that's all. All right, now, what do you write down? Now, here's where it starts to save time. For starters, instead of writing x plus 1, x plus 1 is it's a factor, it's also a polynomial, right? I actually want to write the solution to x plus 1, right? So if this was x plus 1 equals 0, what would its solution be? Minus 1, right? So sometimes this is called the 0 of x plus 1. I find that really confusing because the 0 is minus, that's weird for me. I'm trying to think about what solves this equation. Okay. Minus 1. Now, in the same way, I want to look at this, and instead of writing out the whole thing, I just write out the parts that matter, right? Namely, the coefficients. They're the parts which actually define what happens in this division, okay? So I've got there's a 1 hiding there, right? So I'm going to write 1, 5, 6, okay? Now just before I go any further, if we were dividing by, for instance, x squared plus 6, and there was no 5x there, okay? Just like with long division, there's actually an x term hiding in there, right? It's just that there are 0 of them, right? So in that case, excuse me, you'd write 106. You can't leave it out, screw up everything. Okay. And naturally, if you've got some negative coefficients here, there'll be negative up here as well. So was that a question? Or?
I said 106.
Yeah, if it was 0x.
Oh,
right. If it was just x squared. Okay. So as in, don't skip it. That's all I'm saying, okay? Alright, now, how does it actually work? Well, the first thing you do, and this bit's a bit different, so you just take this number, okay, that leading coefficient, right? You just write it down here. Okay, as you'll see in a second, this middle row here, this is going to be our working. It's going to correspond to all of this stuff, okay? And this last row here, this is going to be the actual solution that we get at the end, which corresponds to here. Okay. All right. We wrote this number down, and then I'm going to do, excuse me, everything I did with long division, but I'm going to kind of do them in reverse, okay? Because this plus 1 is turned into a minus 1, all right? So before we did this multiplying thing, that's how things come from the top to the bottom. So I'm going to take 1, minus 1, you multiply them and you get minus 1. I'm going to write that over here, okay? Because it's going to tell me what the next number is, okay? Now here I subtracted, right? I subtracted to go from one line to the other. Because I've turned this into a minus 1, I'm not going to subtract. I'm going to add, because I've reversed it, okay? So 5 plus negative 1 is 4. Is that okay? Okay, now I'm going to do it again, just like I did over here. 4 multiplied by this, minus 4. And then I add. 6 plus negative 4 is 2. Okay, now I'm finished. Sort of, okay? Now remember, all I wrote was the coefficients up here. So this is just the coefficients, right? But think with me. I'm dividing degree 2 by degree 1, right? So what I'm going to get at the end ought to have degree 1, okay? So these numbers here correspond to the coefficients of the polynomial with degree 1. That's 0. And there's my remainder. Okay? Now you don't have to write that. I could just write x plus 4, remainder 2. Okay? Which, thankfully, is exactly the same thing we got over there. Okay? But let's just go back over that because I know someone who's never seen this before. How does it work? Sorry?
What was this called?
Yeah, okay. I should have probably put that at the top. This is called synthetic division. Despite my fixation with names, I'm actually not entirely sure why it's called synthetic division, so maybe you can go and find out for me.
Not real.
It's fake division.
It's fake, it's, yeah. Well, synthesis actually just means putting things together. Yeah, well, SYN is about combinations of things, right?
Like
so
sync.
like sync, or like syncopation, which is a musical thing. Anyway. Okay, so synthetic division, let me just rehearse the steps again. Okay. Number one, take this leading coefficient and you just write it down. No change. Okay. And then the steps begin where you start to repeat it. Okay. So you take that one, multiply, add. Then you do it again. Multiply, add. That's all you're doing. Okay. It's faster for two reasons. Number one, you just have to write less. Bless you. Number two, addition, surprisingly, is actually faster than subtraction. People often screw up the subtraction, particularly when there's double negatives in here. This tends to be a less error-prone method. Okay. All right. Now the benefits here were not so obvious because it was a pretty short question. Come on. Yeah. All right. So let's do a longer example. Okay. And we'll actually do it with a bigger power, so you'll see the benefit. Yeah.
Is standard division always like a lot faster?
Okay, is synthetic division always a lot faster? Answer, when you are dividing by something specific. So if the factor that I'm after, oh sorry, I shouldn't say factor, if the divisor is something like this, I actually picked this very carefully. It's two things. Number one, it's linear. Right? If you graphed x plus 1, it's a straight line. Okay? So if I were dividing by, say, x squared plus 1, synthetic division would work, but it needs to be modified and twisted and turned, and it doesn't quite work the same way. Not only is it linear, it's monic. What does monic mean? It means the leading coefficient is 1, right? Hence monic. Okay. So in other words, degree 1, leading coefficient 1. Right? Now the reason why it's still worth learning this method, even though it seems to only work with a very specific kind of question, is because this specific kind of question is the one we always do. And that's something we'll address next period. Okay, well not next period, next lesson. Okay?